Hi, this is Grace Griggs representing Team Wingardium Furiosa. This presentation focuses on our concept evaluation process. As described in previous presentations, the goal of this project is to build a machine for the ME2110 competition. The machine must be able to complete a set of 3 tasks listed here. Our selected design and 3 alternatives are discussed here. The first of these designs uses a counterweight system and drawer slides to extend into the arena and egress. A pair of horizontal bars repel the nifflers and scoop up shiny objects. Grindelwald is carried in a mechanical claw and dropped into Azkaban once the walls fall. The Dementor is picked up as the system extends and brought out of the home zone as it egresses. The second alternative design moves to Azkaban on wheels powered by a motor. It picks up the Dementor as it passes over it. An IR sensor detects nifflers, triggering a pneumatic cylinder to push them away. A second pneumatic cylinder supports the Grindelwald subsystem and, when triggered, tilts it upwards, allowing Grindelwald to roll into Azkaban. The machine egresses using the motor-powered wheels. The third design uses a scissor arm to transport the 3 subsystems towards the center of the arena. The Dementor subsystem uses a pneumatic cylinder to strike the Dementor into another home zone. Similarly, the Nifflers and Shiny Objects subsystem uses a pneumatic cylinder to push Nifflers into other home zones. The Grindelwald subsystem holds Grindelwald above Azkaban until a pin is pulled, releasing it. 2 motors are used to extend and egress. The final system, which was selected, uses a pair of drawer slides to transport the Nifflers and Shiny Objects subsystem and Grindelwald subsystem to Azkaban. The drawer slides extend via a pair of pneumatic cylinders and egress via motor. Below the drawer slides resides the Dementor subsystem, independent from the subsystems above. The Nifflers and Shiny Objects subsystem consists of 3 parts. The dislodging arm uses friction to remove the Nifflers from their nests. The sweeper arm then uses the rotation of Azkaban to sweep the dislodged Nifflers and nested shiny objects into the sorting box. Due to their size difference, shiny objects fall into the sorting box while Nifflers roll off the top and into another home zone. This subsystem was tested during lab and scored 140 out of a potential 216 points. The Dementor subsystem consists of a scissor arm powered by a motor using a rack and pinion mechanism. A primed mousetrap is attached to the end of the arm so that it snaps closed once it makes contact with the Dementor. Then the motor reverses, transporting the Dementor as the arm retracts. Once the scissor arm is fully retracted, the Dementor is completely inside the starting zone. The Grindelwald subsystem consists of a circular plastic housing attached to a primed mousetrap. After the machine has run for 28 seconds, a motor on the frame pulls a string attached to the release pin. This frees the mousetrap to fire, placing Grindelwald into Azkaban. The motor continues to run, pulling the whole subsystem, allowing it to egress. Each design concept was rated on how well it satisfies each of the customer requirements from the House of Quality. These ratings were collected in this evaluation matrix. As seen here, the selected system outperforms all alternative designs in every category except for safe operation, aesthetically pleasing, defends home zone, and track flexibility. These negatives are offset by the fact that it scores better in the most heavily weighted criteria, addresses all tasks, scores well, performs consistently, and reliable triggers. In particular, it scores a 4 out of 4 on addresses all tasks and reliable triggers. As seen here, the selected system scored the highest total score out of all concepts and thus was chosen as the final design. Moving forward, the team has several conclusions to consider. First, minimizing the use of sensors increases reliability by reducing the chance of misfires. Second, the selected design has several key strengths, mainly a focus on simple mechanisms and avoiding complex mechatronic systems where possible. These simple parts can easily be replaced or duplicated should they become non-functional. Finally, planned design changes include adjustable height mechanism to account for differences in track dimensions, refining the trigger mechanism, and improving and finalizing parts for the final competition.